Okay, so we're going to use all of our triangle congruence theorems today to do, I'm going to say light proofs. We're not going to do two-column proofs or anything like that. We're just going to use our congruence theorems to prove that pieces of triangles are congruent. Now remember, from one of the first lessons we did over triangle congruence, the CPCTC, that's an important one. What CPCTC says is, if I can prove that two triangles are congruent, that tells me that every single piece of those triangles are congruent, which is what we're going to be using a bunch today. Refresh my memory though, what were all of the triangle congruence methods we learned? Side, side, side. Angle, side, angle. Nope. Side, angle, side. Yep. And what was the last one? HL, hypotenuse leg. So those are the big five that we're going to be using. And so a lot of the questions are going to look like this. It's going to say, can you justify that one piece is congruent to another piece? So FC and EB are these two pieces. Here's FC going all the way across, and here's EB. Can we prove that those two pieces are congruent? Yeah, probably. But using which one of our theorems? So let's start off with what we know. The little diddly-doos on the bottom tell us that segment AB is equal in length to segment CD. That's what these marks right here tell us. No, because I'm saying the length is the same, not that they're, you need the lines if you say they're congruent. I'm just saying the length is the same. Now you'll notice that is not the entire hypotenuse of the triangle. It's just a piece of it, AB and CD. I'm missing that little piece in the middle, which is BC. But the reflexive property tells me that BC in the first triangle is equal to BC in the second triangle. Right? BC in both, they should be equal. That tells me that if I took the AB and added BC, it would be equal to if I took the CD and added BC, which means AC is equal to BD. I'm going to assume that's not a real question. So what we showed here is that the two, I still don't know if it's hypotenuses or hypotenusae. I think it's hypotenuses, but I'm not sure. The two hypotenuses are congruent. Why? Very good. In order to use hypotenuse leg, it must be a right triangle, because a right triangle is the one that has a hypotenuse. So we have now proven, as Emily said, using HL, that triangle AFC is congruent to triangle, we got to make sure we get the order right, AFC would be congruent to DEB by the HL theorem. Now, our goal was not to prove that the triangles were congruent. Our goal was to justify that segment FC and segment EB are congruent to one another. But if the triangles are congruent, then every piece of the triangle is congruent. So we could say that FC is congruent to EB because we just proved the triangles are congruent and corresponding parts of congruent triangles are congruent. CPCTC. And that's the way, I like it. I think every time I make an awesome joke like that, I should hit a button that does like a rap horn. That's the way I like it. And the lights dim and there's lasers shooting out across the room and there's like smoke that comes up from behind my chair. And then I stand up on the desk and do a flying pile driver right onto Christian's table. And everybody cheers and they carry me out on their shoulders and they chant, USA, USA, Taylor's the best, Taylor's the best. And then I walk outside and everybody's holding up signs that says like, Taylor's the champion. And then the whole town has turned out to give me a parade and they put me on a throne and drive me down Main Street. And everybody from the county is on both sides and they're just like throwing flowers and candy and chicken nuggets at me. And they're like, you're the best, you're the best. Okay, and then I get to the end of the parade route and they're like, because you made such an awesome joke, this mansion is yours. And I pull up and it's got like 2 BMWs in the parking lot and it's like this giant mansion. I'm an old man. We don't aspire to those cars anymore. We want something sensible that's safe for the children. Okay. A BMW is that expensive, my dear. Excuse me, is this your dream or is this my dream? When you get carried out of here on your shoulders for making an awesome joke and you become mayor of the town, then you can have whatever kind of mansion and cars you want. But did you make an awesome joke and then after doing a flying pile driver, get a parade and become mayor of the town? No, you didn't. I did. It happened. We were all there. Everybody remember where you were when I was spontaneously elected mayor just on the strength of my awesome jokes. They'd be like, you know what? Let's forget the election. Taylor's our president now. Because the 2 candidates we have now, they're not as funny as Taylor or as good looking. At least a day. As much chaos. Yeah, I would immediately ask for all the government secrets so I could put them on social media. By the time they brought charges against me for national security divulgence, then I would already not be the president anymore. Be like, nope, sorry, my 1 day is up. Somebody else's problem now. I think if you were president, a really funny thing to do would be to tell people things that were not true just because you know they would believe you because you are the president. Did you know that it's actually safe to just float out in space without a spacesuit? We have to pump the oxygen onto the earth so you can breathe. People be like, oh my God, the president says that it must be true. Why? What's the, I only see side AB and side BC. So I know AB is congruent to CB because that was given. It was isosceles triangle. And I know that angle ABD is congruent to angle CBD. That was also given in the diagram. What'd you say was the other side? BD. How do I know that BD is congruent? That wasn't given to me. Ah, because BD is a side that appears in both triangles. BD is one side of the left triangle and also one side of the right triangle. So I could say that side BD is congruent to side BD. That's the reflexive property. Everybody's favorite. Which means yes. So I would say, let's make sure we get the order right. Triangle A, B, D is congruent to triangle C, B, D. And as Emily said, the reason is side angle side. We have two congruent sides and the included angle. Now, what I wanted to prove is that the base angles, CAB and ACB, let's go ahead and mark those in there. CAB is this one, and ACB is this one. Are those angles congruent? Angle CAB is congruent to angle ACB. How do I know? Because I proved the triangles were congruent and corresponding parts of congruent triangles are congruent. And that's the way I like it. Bah, 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 bah. You just got proof. Bah, 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 bah. Where's the applause? I need my, no, I need my applause button. One person going, boo! You can't please all the people all the time. I can't think of a single state that would be upset about me being president. Do they? Not everybody can be friendly like us in Texas, who are known for our friendliness and tolerance. Why can't you be more like Texas, everybody? We'll send you all hats. You know what? Barbecue is like one of the most divisive things in the whole wide world. Like, there are multiple states that are like, we have the best barbecue, and if you disagree with me, then I will fight you in the bed of my Ford F-350. I don't know why people are. I like Texas barbecue. To me, it's much more interesting to talk about who has the worst barbecue, and I'm ready to declare a winner, and it's Florida. Oh my gosh. Florida's barbecue is so bad. But I like Disney World. I like how cute it is that they always like get in like the worst kinds of situations by accident. They're like, Florida man loses his alligator at a drive-through Wendy's. That's fun. The what? Oh yeah, that was a Florida guy who was smuggling the flying squirrels. See, there's lots of cool things about Florida. Lots of cool things about Florida, just their barbecue is not one of those things. Wild what? Oh, I don't know. I've been to Florida a couple of times and I've never seen iguanas. I have seen crocodiles that just like lay on the side of the highway. So if you get a flat tire, you got to be careful where you pull over to fix it. Oh, is it alligators? I've been to Florida a bunch of times. Well, I mean, that's the whole story. I went to Florida a couple times. Because Disney World's there. Disney World is awesome. My child is too young for Disney World. Non-existent, which is pretty young. So I went ahead and did a couple of things here. I did the right angles that were given to me because of those perpendicular lines. So for example, angle BFA is equal to 90 degrees, and the other one was angle CEA, also 90 degrees. My angle CEA, I'm sorry to say, does not look as 90 as I would like. But the reason I know this is because of the definition of perpendicular. Now this is looking pretty complicated. I think maybe it might be a good idea to go ahead and highlight the triangles. ACE is this guy. See, that angle E does not really look 90, but don't judge things based on what they look like, kids. It's what's inside that counts. And then A, B, F is the other one. Those are the two triangles that I'm trying to prove are congruent. So what do I have that's, what do I know already about these triangles? FA and FA. FA and EA are congruent. Okay, that was given. Okay, so I know that segment FA is congruent to segment EA. That was given. And I think it's probably okay for me to say that those two angles are congruent since they're both 90. Probably safe for me to say that angle BFA is congruent to angle CEA. Well, you know what? I need to elaborate on that a little bit. So if angle BFA and angle CFA are both 90, that's how I know by substitution. And then this reason would actually be the definition of congruence. Let's be a little more specific here. And you know what, just to be super accurate and impress the ladies at the math party, let's write out substitution so that nobody thinks we mean subtraction. I'm going to call that step 3A. I'll jump the gun, I skipped a step. You get the idea. So I've got a side. This is a side. This is an angle. What else do I still need to prove? What's another way? Another way I could get at this. I do? What is it? That was step 3. I said the two 90-degree angles are equal to one another. What's another piece of these triangles I could prove was congruent that would use one of our congruency theorems? EDF isn't an angle in either triangle. DEA? We already did. That one's 90. FAB and EAC? Yes, those are the same angle, which means they are congruent by reflexive property. So we could say, let's do step 4. I'm just going to call them the same thing. I'm going to call them both BAC. Angle BAC is congruent to angle BAC. As Emily said, that is the reflexive property. So there's another angle that we proved was congruent. So we have two angles and a side, but now it starts to matter, is it the included side or not? Because we have an angle-angle side theorem, and we also have a angle-side angle. So is the side included in between the two angles or not? Well, let's see. If I'm looking at, I'm just going to look at the green triangle here. Angle, side, angle. And if I look at the yellow triangle, angle, side, angle. So the side is included between the two angles. So I can now prove triangle ACE is congruent to No, that's in the yellow triangle. This is, I should have used different colors on. This is the green triangle. And this is the yellow triangle. I should have used different colors. My bad. I just like red so much. It's a teacher thing. We just really like putting red on everything. We find that it demoralizes you and that brings us joy. Well, these have been pretty informal proofs. We're just kind of writing the reasons next to each one of them. I think before we wrap up for today, we probably should just go ahead and do a 2-column proof. I feel it in my bones. That was a pretty good one. I think we can do better. Last one. This is going to be a 2-column proof. I know, I'm excited too. I love proofs. You don't say anything unless you can prove it. Except for that sentence that I just said about not saying things unless you can prove it. But everything else besides that sentence, don't say it if you can't prove it. Okay, let me draw you a pretty picture. Let me draw you one of my usual flawless diagrams. They've always been perfect. Absolutely no respect at all. No respect. Close enough for government work. All right, fine. It looks like crap. I'll try again. It's not close enough. I hear you. All right, that's all right. I can live with that. You look like a paper airplane. Golly, there's no reason for you to make fun of my one shortcoming, which is that I'm not good at drawing triangles. I know, I know, I know. They didn't teach us that in geometry school. How to draw triangles. I'm glad you're putting blame in the right place. Someone else besides me. Nope, not listening to that part. All right, stop right there and give you a minute to catch up. It's probably going to take you way longer to draw your triangle because you don't have as much experience as me. So you may have to. So mean. I don't know. I see at least 4 triangles there, maybe more. You can't count, but you're insulting the teacher. So let's start off like all good proofs do with the given. So the first thing was xj is congruent to yk. Let's go ahead and mark that on there. Xj is congruent to yk. And then the next thing we were given is that xp is congruent to yp. So we'll go ahead and mark that. xp and yp, because I drank too much. And then the last thing I was given was angle zxj. See, if I had my applause button, I would hit it right now. zyk. So we'll mark that as well. So zxj is that angle, and zyk is that angle. And all of these sweet, delicious measurements were given to us. Darn nice of that problem to give us stuff. I think so. Okay. Hit me. Yes, that was given. How come? Very good. So what Ellie said was that angle JZX is congruent. Oh, you know what? We need to first say that they're vertical angles. And KZY are vertical angles. That is the definition of vertical angles. And that means they are congruent. So angle JZX is congruent to angle KZY because vertical angles are congruent. Yes. So we're going to say, Emily says that we're going to say JX equals KY. That is the definition of congruent. We were given that they were congruent. Now we're going to say they're equal. And now we know that XP plus JX equals YP plus KY. Actually, I don't need the line on either one of those now that I think about it. That is the segment addition postulate. Which means JP equals PK. It should be JP equals KP, I guess. We're going to call that substitution. Is it substitution? I don't know. We skipped a couple steps in there, but you get the idea. Cool. Are we? We haven't proven anything. Okay, I like that. Angle JPK is congruent to angle JPK. Derp, because of the reflexive property. So I'm going to go ahead and mark that on our diagram. Before you get into any angles, we do have a pair of triangles right now we could say are congruent. Yeah, we can prove JZX and KZY are congruent. How do we know that? Yep. Triangle JZX is congruent to triangle K. You even said them in the right order. You're so smart. And that's angle side. So now those angles that we were trying to prove, we can just say that angle XJZ is congruent to angle YKZ, because we proved those two triangles are congruent and corresponding parts of congruent triangles are congruent. Right, kids? Man, I thought I drew that line too long, but we're still going. I think we actually know enough to say the big triangles are congruent too, because what we just proved with that was that these two angles are congruent. Are you up to four? 1, 2, 3, 4. Now we can prove that the not the tiny triangles. We proved the tiny triangles are congruent. Now we can prove the big triangles are congruent. How? proof so big it won't fit on the screen. Let me go portrait mode. There we go. That's a little harder to read, but now you can see all of it. Oh, I don't know why I wrote triangle for that one. That was silly. I think we're ready to say the two giant triangles are congruent. And there's actually two ways that we can do this. We have gotten more information than we needed. We know more congruent pieces than we need. That part with the segment addition postulate allows us to use angle side angle, because now we know the side in between P and J are congruent. But even without doing that segment addition postulate, we still could have done it by using which pieces? Angle, angle, side. Angle P, J, and JY, and then angle P, K, and KX. So we could do angle, angle, side, or angle, side, angle. I don't care. Pick your favorite. And that means, finally, we can prove segment JY is congruent to segment KX because we proved the gigundos were congruent and corresponding parts of congruent triangles are congruent. So I'm going to go through and highlight the parts here that were optional. This right here, and yes, I'm highlighting yellow in yellow. These parts right here, we did not technically need those in order to do the proof. We could have done it just with the two angles in the side, but because we did that segment addition postulate piece in the middle, we had another way to prove the triangles were congruent. And when you're doing a proof, the most important thing to keep in mind is it's always possible to make it last just a little bit longer if you want to. We could have also done side, 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 now that I think about it. We could have done side, side, side as well, because we figured out all the sides. So basically, whenever we did this proof, we proved almost every single piece of these triangles was congruent before we actually did the proof at the end. Did we actually need step 10? I guess we did. We did need step 10. But lordy, that was a good one. That was a doozy. Me too. I'm glad we didn't stop before we got to the 11-step proof. I mean, it really could have been an 8-step proof, but why stop at 8 when you can get double digits? Think how disappointed you would all be if the proofs ended early. I know I would be. Who has questions for me other than, my God, why have you forsaken me? I can answer that. It does not. Anybody else? Yes. Because then that's why it would have been an 8-step proof. If our step number 4 had been to prove those two triangles were congruent, then we would have been 3 steps from the end. But that one was tricky because you had to prove 2 different pairs of triangles were congruent. You had to get the little pair first in order to know the big pair was congruent, to have enough information. Any other questions?